Okay, today we're looking at section 6.1, how do you solve radical equations? When you think radical, immediately think roots, square roots, cube roots. We can take any root. An nth root is written as like this with the n inside the root here with the a there. The n here, the term for that is the index. Okay, so if I put a 3 there, it's a cube root of 8. Okay, the cube root of 8 is 2. And the reason it's 2 because roots and powers are inverses of each other. So 2 to the cube, 2 cubed is 8. 2 times 2 times 2. So the cube root of 8 is 2. Okay, your calculator has an nth root button. Looks something like that, typically. Okay, so you can find that button on your calculator. So we could find the fourth root of 81. So the fourth root of 81 would be written before is your index, the fourth root of 81. So to figure that out, think about what number would I have to raise to the fourth power to get 81. And again, this would be 3. Whoops, 3. Because 3 to the fourth power is 81. Okay. Now if there is no index written there, we assume the index is 2. It's a square root. So if we have just something like that, that's a square root. It's just like putting a 2 there. Otherwise, the number in there is the index and it's the root. Okay, roots are also fractional exponents. Write that down. So the fourth root of 81 is the same as 81 to the 1/4 power. In general, the nth root of a is equal to a to the 1 over n. So the root becomes a fraction here. And the index is the denominator. Okay, and further, if I have the nth root of a to a power of m, or I could write it like this, means the same thing. It is the same as a to the m over n. Okay, so this is my numerator, this is my denominator. And now, why is this helpful? Let's try to evaluate these expressions. And remember, evaluate means to figure out the answer. So, 16 to the 3/2. Okay, so in order to evaluate that, I want to rewrite it. And I want to rewrite it from this to this. So it's going to be, this is my root, so it's the square root of 16 cubed. So typically you want to do the root first. So what's the square root of 16? That's 4. So this is 4 cubed, which is 64. So we can evaluate that without using a calculator. Okay, let's try one more. How about 4 to the 5/2? So that's going to be the square root of 4 raised to the 5th power. So the square root of 4 is 2. 2 to the 5th power is 32, I believe. Okay, how about 9 to the -1/2? Okay, now do you remember negative exponents? How do we make those positive? We put them in the denominator. This would be the same as 1 over 9 to the +1/2, which is 1 over the square root of 9 to the 1, which is just 1 over 3. So that's 1/3. Okay. And then, let's do one more here. 81 to the 3/4. So we want to know what's the fourth root of 81 cubed. Okay, the fourth root of 81 what number do I raise to the fourth power to get 81? We did that one way back here, so it's 3. So this is 3 cubed, which is 27. Okay, so by using these properties, we can adjust the form and evaluate those expressions. Okay. So now let's just do a little bit of practice going back and forth in these forms. Can we rewrite these? The cube root of 24. So the cube root of 24, if I want to rewrite it into fractional form, it would be 24 to the 1/3 power. How about the fifth root of 2 to the 4th power? Would be written as 2 to the 4/5 power. We can't evaluate these any further because we can't take the fifth root of 2 without a calculator. So we can just leave it. How about going the other way? 3 to the 3/5. So this is my root, so that's the index. So it's the fifth root of 3 to the 3rd power. Okay? Alright, so let's move on to answer our essential question here, which is how do you solve radical equations. So let's look at what a radical equation is. I need a little room here. So okay, x cubed equals 64. Okay, so we know how to solve squared equations. We just square root both sides. Similarly, we just cube root both sides of these. So x is going to be the cube root of 64. The cube root of 64 actually is 4 because 4 cubed is 64. So these are pretty straightforward. Second one here. My phone rings. 1/2 x to the 5th equals 512. How would I solve that? First I have to undo the 1/2, so I could multiply both sides by 2. That's going to get rid of that, so I'm going to get x to the 5th equals 1024. Take the 5th root. The 5th root of 1024 is my solution. Not sure if that comes out. You could actually figure that out on your calculator by using your nth root button on your calculator. Okay, otherwise on your calculator, I'm looking at my calculator right now, under math, here's my root button right there, x root. So if I want the 5th root of 1024, I would actually have to type in the index 5. Let's clear this. Type in the index 5, hit math, go to the x root, whoop, went too far, and then 1024, and it tells me it's 4. 5th root of 1024 is 4. Okay. And that's because 4 to the 5th is 1024. How about this one? X minus 2 cubed equals negative 14. In this case, we have to cube root first to undo the cubed here. Now, here's a question. Can I cube root a negative number? I actually can cube root a negative number. Because I can, if I cube a negative number, the result is negative. Okay, so in this case, I can cube root a negative number. The cube root of negative 14 is actually negative 2.41, I believe. So then I can add 2 to both sides and get negative 0.41. Okay. Last one. Except I missed the 2 in front of there. Let me fix that. 2 times x plus 5 to the 4th equals 32. So my first step is going to be divide by 2. Gives me 16. Now I take the 4th root of both sides. Okay. The 4th root of 16 is 2, because 2 to the 4th is 16. However, negative 2 to the 4th is also 16. So something we have to remember here, if I take an even root, I have to consider plus or minus. If it's an odd root, I don't have to worry about it. There's only one solution there. But so if I have an even root here, I have to do the plus or minus. The 4th root of 16 is 2. So if I subtract 5, I get x equals negative 5 plus or minus 2. Losing some room here. So those are two solutions there. X equals negative 5 plus 2 is negative 3. Negative 5 minus 2 is negative 7. So those are my two solutions. So again, consider plus or minus when I take an even root of both sides. So these are the types of equations that are going to be in this section. Fairly straightforward to solve. The only difference is we're taking bigger roots than square roots like we have before. And then we have to remember, if it's an even root, we have a plus or minus here. If it's an odd root, we don't have to worry about it. We can just get our one solution. That is it for section 6.1.